Hello, am I audible? Hello, hello.
Yes, sir.
Okay, so there was break in the internet connection, so it took so much amount of time. Okay, let me start with the previous class. So in the last class, you know that. Okay, in the last class, you know that uh, L is the number of levels. Okay, and it depends upon the number of bits 2 to the power of k, where k is the bits. Okay, number of bits which is used to, it is the number of bits which is used to represent the picture element. Okay, there will be L levels which is equal to 2 to the power of k, where k is the number of bits. Okay, and m is the number of rows and n is the number of columns. Okay, if the number of rows equals number of columns, then it will be called as a square image. Okay, now let us consider three images. So these are the three images which indicates the different amount of information which is stored in this image. Okay, in the first image there is a low level of image. Okay, there is only a woman which is being displayed in the image, so it is consisting of only a low level amount of information. Whereas if we consider the second image, here there is a human being, along with that there is a camera, there is a building behind him in the background image, so it is consisting of more amount of information. Okay, similarly if we come for the third image, so there is a crowd. Okay, this is consisting of more amount of image. So if we need to represent the image by making use of levels or the intensity levels and the number of rows and columns, we'll be making use of a graph which is called as iso preference curves. Okay, this vertical line indicates the k, or the y-axis indicates the k, which is number of bits. Okay, and which is the x-axis represents the number of columns or number of rows. Okay, if you look at the graph, okay, if you look at the graph, so this line indicates the representation of face. So this line indicates the representation of the face. If we look over here, n is increasing. Okay, if we go in this direction, n will be increasing, and in this direction the k would be increasing. So here if we look over here, the iso preference curve, okay, iso preference curve of the face is tilting upwards. Okay, if it is tilting upwards and towards right, the quality of the image will be very high. Okay, the image quality would be very high. So the image quality would be very high if the curve tilts upwards and towards right, the image quality would be very high. So if you look over here, the number of columns is very high and the number of k, okay, the number of bits is also very high. Okay, next comes the previous, that is the second image. Okay, so this, okay, this requires, this is having more number of columns and it is also having highest number of k. If we come for the second, okay, cameraman, so if you look over here, it is not turning upwards and towards right. Okay, so this indicates it's a poor quality or poor quality image. Okay, the image is not of a good quality. Okay, so this is of poor quality. Okay, so last one, if we consider the crowd, okay, if it is almost vertical in nature. Okay, it's almost vertical in nature. This indicates, okay, although it is not more clearer, okay, although it is not more clearer, it also indicates another point, that the amount of information which is present in the image, as if it is having more number of data, okay, we require less number of n, we require less number of n, and also we require less k. Okay, the value of k and the value of n is minimum. Okay, the value of k and the value of n is minimum when the amount of data which is present in the image is more. So this is the information which we get with the help of isopreference curve. Okay, so first thing is the face image. Okay, the face image is having least amount of data. So with the given number of columns and k bits, it is tilting upwards and towards right, so the image quality would be very high. So when we come for cameraman, the amount of information is increased, so it is not going up and towards right, so this will be having poor quality. And if we consider the crowd image, it is having the most amount of data. Okay, so here it is almost a vertical line. Okay, there is another thing which we can establish out of this vertical line, is that when the amount of data which is present in an image is more, we require less number of columns and we require less number of bits, okay, to represent the crowd. So this was regarding the isopreference curve. Okay, now next let us consider the problems. So before going back, the first concept which you need to know is neighbors. Am I audible? Hello? Hello?
Yes, sir.
Okay, so this is very important topic. You'll be solving problems
Yes,
using,
sir.
okay, you'll be solving problems this using this method. Okay, first thing is you just need to know the neighbors. Okay, so neighboring cells. So when we consider image, there will be two axes. Okay, one would be called as x axis. Okay, and the other would be called as y axis. Okay, so let us consider a 3 cross 3. Let's consider a 3 cross 3 image. Okay, so x axis and y axis. If we consider a neighboring cell, so there will be three types of neighboring cells. Okay, one is called as n4 of p. Okay, n4 of p, and the second one is called as n diagonal of p, and the third one is called as n8 of p. So these are the three types of neighboring elements. P means P is the center element which is present in the image, and there will be four neighbors to this P element. And D means these are the diagonal elements which are present around the P. Okay, N8 means 8 elements which are present around the cell. Okay, we'll be considering this as P. Okay, we'll be considering this as P. So this, okay, we'll be considering this as X, and we'll be considering this as Y. So this is your center element. So this element will be considered as x minus 1, and this would be considered as the next element, which is x plus 1. Here this would be considered as y minus 1, and the next element will be considered as y plus 1. Hello?
Yes, sir.
Okay, now let us consider the first neighbor, n4 of p. Okay, so if we consider n4 of p, so the upper element and the lower element, next adjacent element. Okay, this is your adjacent element. So these are called the neighbors, okay, of p in case of n4 of p. So we can define the neighbors as, which are the neighbors? X is one of the neighbor. So this is x, and in y axis is what? This is x, and here, hello, I'm audible?
Yes, sir.
Okay, so this is
Yes,
x.
sir.
In this line, if we come this x, from here it is y minus 1, x comma y minus is one of the neighbor. Then the next neighbor, if we consider this, the value is what? Y and x minus 1. So it is y and x minus 1 is another, y and x minus 1 is another neighbor. Next, if we come over here, so y plus 1 and x, so it is x comma y plus 1, and the next element here, it is what? Y and x plus 1, so that is x plus 1 comma y. So these are the four neighboring elements of point P, which is placed at the center. Okay, clear with this? Hello? Hello.
Yes, sir.
Okay, you just need to know how to get these coordinates. It's very important to know how to write these coordinates. Okay, so this was your first element x. Okay, so you written x is in y minus column, written as x comma y minus 1. The next element is this element. This is placed where? In x minus 1 and y. So I written it as y and x minus 1. Next third, this one you could have written this as x minus 1 comma y. Okay, so that it would be more clear. Okay, okay, next is what? X minus 1 comma y. Next the third element, this one, this is along the x axis and y plus 1, so x comma y plus 1. And the fourth element, this is along y and x plus 1. I written it as x plus 1 comma y. Okay, so these are the four neighboring elements. Similarly, if we need to consider nd of p, okay, if we consider nd of p, so this will be the neighboring elements, okay, which are present in the diagonal axis. So if we consider this as 3, again, if this is your point p, okay, if this is your point p, so the diagonal elements, okay, so the diagonal elements are, so this is your first diagonal element, okay, so this is your second diagonal element, and this is your third diagonal element, and this is the fourth diagonal element. Okay, so these are the four diagonal elements, whereas these are the four neighboring elements. Okay, so now if you need to write the coordinates, again what you need to do, you take this as x, and this would be your x minus 1, x minus 1, and this would be your x plus 1, and again this would be your y. So the previous would be y minus 1, and the next coordinate would be y plus 1. Okay, now if we consider the coordinates of p in ndp of p, d means diagonal, so the first one, okay, if we consider this one, so the value is what? X minus 1 comma y minus 1. And the next one, let's consider this as the second element, so that would be x plus 1 and y minus 1. Next, if we consider third element, so that would be x minus 1, it would be x minus 1 and y plus 1, and the next element would be x plus 1, x plus 1 and y plus 1, x plus 1 and y plus 1. Okay, so these are the four diagonal elements. Okay, clear with this diagonal elements? Hello, hello.
Yes, sir.
Okay, so these are the four diagonal elements. Okay, so if we consider 8, okay, means it consists of all the neighboring elements. Okay, it is nothing but a combination of n4 of p and ndp of p, that will be called as n8 elements. Okay, so these are regarding the neighbors. Okay, next let us consider the problem regarding this. So if we consider here, okay, consider the image segment shown over here. You just write down v equals, just note it down in the notebook, v equals 0 comma 1. Write it down, v equals 0 comma 1, v equals 0 comma 1. Okay, and compute the length of the shortest 4, 8 and m path. Okay, we need to find the shortest 4 path, 8 path and m path. Okay, so here we'll be dealing with a concept called as adjacency. Okay, v equals 0 1 ಬರ್ಕೊಂಡ್ರಾ? I will turn it down. Hello, hello.
Yes, sir.
Okay, now you just copy down
Yes,
this
sir.
you just copy down this matrix: 3 1 2 1, 2 2 0 2, 1 2 1 1, 1 0 1 2, 1 0 1 2. ಆಯ್ತಾ? Is it over? Hello? ಆಯ್ತಾ ಬರ್ಕೊಂಡೆ? Hello?
Yes, sir.
Okay, now they are asked to find the path. Okay, we need to find the path from point P to point Q. Okay, we need to find the path from point P to point Q. So this is your P. Okay, this is your point P, and this is your point Q. We need to go from this location to this location. Okay, from this location to this location using four ways. Okay, one is called as shortest 4, the second is called as shortest 8, and the third one is called as M path or M connected path. First let us look at the 4 path. Okay, in case of 4 path, it is similar to your n4 of P. Okay, as I said, n4 of P. So you just need to look at the, if this is the element, so the upper number and the lower number, or the numbers which are side by, will be called as 4 path. Okay, we just need to verify V. Okay, V is containing what? 0 and 1. Okay, V is containing 0 and 1. When you go from 1 to, that is from point P to point Q, you will be connecting the next data only using the data which is present in V, that is 0 and 1. Right now you are present over here. So the neighboring 4 path element is, you can move towards right or you can move towards upwards. Okay, 0 is also present in V. Okay, again 1 is also present in V. Okay, so you can move either towards right or you can move towards upwards. Clear with this? Hello? Hello? Hello?
Sir, once again, sir.
So 4 path means it's equivalent to what? 4 neighbors. Okay, if we consider this as a point, okay, if we consider 2 as a point, which are the neighboring elements? It can be the upper element or it can be lower element, or it can be the right element or it can be the leftmost element. Okay, if we consider this as a point, here this is nothing but point P. Okay, this is your point P. Similarly, this is what your, okay, which are the 4 neighboring elements? So it can be 1, okay, or it can be 0. So at the bottom there is no number and at the left there is no number. Okay, so there are only 2 possibilities. Okay, you can move upwards or you can move towards right. Okay, and again this number, the number which is present here, 0 and 1, it is present where? In your set V. So you can move towards right or you can move towards up. Clear with that? Hello?
Yes, sir.
Okay.
Sir, but can't you take the upper letter?
Yeah, if you take the upper letter, you cannot move upwards again because 2 is present over there, right? Hello? If you move upwards, okay, if you
Sir,
move
yes.
upwards, so there is 1 which is present over here. Okay, in the next step, when we try to move from, the ultimate goal is to move towards this number. Okay, when you come to this location, okay, to any direction. Okay, when you go upwards there is 2. Okay, but 2 is not present in V is equal to 0 comma 1. Again towards right 2 is present, again it is not present in the V which is 0 and 1. So it is waste in moving in the upward direction. So what we are doing is, instead of moving upwards, so we'll be moving towards right. So 1 it is moved towards right. Clear with this? Hello?
Yes,
Yes,
sir.
sir.
Okay, now this is your point. From here you need to move using what? Only 4 path. Okay, which are the 4 path? 2, 1 and 1 is the 4 path. You cannot move to 2 just because there is no value 2 is present in this V. So what you can do is you move towards right. Okay, now from here where do you need to move? Hello?
Upward.
Upwards.
Upward.
Okay, you'll be moving upwards. Okay, you'll be moving upwards.
Upward.
Okay, next from this location you can move either towards right or you can move towards upwards, right? Clear with that? Hello? Hello?
Yes,
Yes, sir.
sir.
Okay, now let us move towards right. Okay,
Yes,
let us
sir.
move towards right. From here again there is 2 but 2 is not present in this set, so you cannot reach to point Q. Okay, if you had reached again in the upward direction, again there is no value 0 or 1. Again this is, you cannot reach to point Q from here also. Okay, so what does it indicate? It indicates that there is no 4 path connection between P and Q. Okay, since you are not able to reach point Q from point P using 4 path connection, so it indicates that there is no 4 path connection between point P and point Q. Clear with that? Hello?
Okay, sir.
Okay, so that is what being solved over here. Okay, now you take the same
Yes, sir.
image over here, move from this point to, move from this point to this point, move from here to here, moved here towards upward. From here there is no path to connect to the point Q, so there is no which is possible by using what? 4 path method. Okay, clear with this? Hello, clear with this concept? Any doubts?
Yes, sir.
Okay, next we'll be using 8 path. Okay, they are given it as 8 path. Okay, so you just take the same values again. Okay, you note down the same values again. So now this is your point P. Okay, this is your point P. I will also be taking this image. So now we'll be using 8 path. Okay, in case of 8 path you'll be using 8 neighbors. We'll be using n8 of P. Okay, you'll be using n8 of P in case of 8 path. What does that indicate? If P is a point, if P if P is a point, all the values, okay, all the values which are surrounding, okay, all the values which are the surrounding point P belongs to what? n8 of P. Now let us consider this is your point P. Okay, so which are the 8 n8 of P? 1, 2 and 0, all these are or n8 of P. But among these data you just need to check which is present in the set V. Okay, out of these two, 1 is present in the set and 0 is present in the set. So, and if you move upwards, what happens? 2 is around this 1, so you cannot move forward. So what you'll be doing is you'll be moving towards 0 which is present in the set. Clear with that? Hello? Hello?
Yes, sir.
Yes.
Okay, next from this point we need to move to which location? To which location?
Right, sir.
Right side. You can move towards
Right.
right. or also you can move towards one diagonal element, okay, which would be more appropriate, moving diagonally or moving right?
Diagonal.
Diagonal, right? So both are 8 point itself,
Sir.
okay. You can move towards right, okay, you can move towards right, or you can move towards diagonally, okay. If you move diagonally, what happens is you'll be eliminating two paths, okay. Instead of moving from 0 to 1 right, then will be if you move diagonally, instead of two paths you are making use of only one path, okay. So they will ask for what? Shortest path, okay. Instead of using two paths, if you move diagonally, it consumes only one path, so we will be moving diagonally, okay. Clear with that? Hello?
Yes, sir.
Okay. Next, from this point, where
Yes.
do you move? From this point, where do you move?
Upwards.
Upwards, okay. So you'll be moving upwards,
Upwards.
okay.
Zero.
Next, from this point you'll be moving diagonally, okay. You'll be moving
Diagonal.
diagonally, okay, towards the end point, okay. Using shortest eighth path, we have moved from point P to point Q, okay. Now you just count the 1, 2, 3 and 4. The shortest path is how much? 4. So you consume 4. So I consider 4, okay. This is the shortest path is 4. 1, 2, 3 and 4. So this is your 8 path connection, okay. Clear with that? Hello?
Yes, sir.
Okay. So this
Yes,
is
sir.
okay. This is what is being shown in this figure, okay. The shortest path is how much? 4, okay. The next one is called as M connected, okay. So next one is called as M connected. So there will be 4 types of path. One is 4 path, the next one is 8 path, and the last one is called as M connected, okay. So this is a bit complicated when compared to 4 path and 8 path, okay. This in the next class, okay. Clear with this concepts, right? Neighboring elements and 4 path and 8 path. Clear with this, right?
Yes.
Any
Yes,
doubt?
sir.
Any doubts
Yes,
regarding
sir.
this? Any doubts regarding this?
No, sir.
Okay, you just get clarified with this problem, okay, when coming to the next class, okay. We'll be doing M connected path in the next class, okay. Thank you.
Thank you, sir.